Imagine a wall designed to stop an unstoppable force. In 2011, Fukushima's massive seawall, built to protect against tsunamis, was catastrophically overtopped. Was this a failure of engineering, or a deeper flaw in our understanding of nature's true power?
Join us as we uncover the crucial miscalculations that left Fukushima vulnerable.
9.0 on the moment magnitude scale. That isn't a tremor, that is the Earth's crust screaming. The Pacific plate didn't just slip, it shoved the seabed 50 meters upward in a matter of seconds. Do you understand the thermodynamics of that? Elena, we are talking about enough energy to power Los Angeles for a year, released in a single geologic spasm. And we built a concrete picket fence and called it invincible.
It wasn't a fence, Mark. It was a multi-billion yen depreciating asset that the Tokyo Electric Power Company used to purchase public complacency. They didn't build a wall to stop the ocean. They built a wall to silence shareholders. The failure didn't start when the water hit the concrete. It started on a spreadsheet 3 decades prior when they decided that a 5 and 7 meter tsunami defense was economically feasible in an active subduction zone.
Economic feasibility doesn't dictate hydrodynamics. Physics is absolute. When that seabed displacement hit the surface, it didn't create a ripple. It created a wall of laminar flow traveling at the speed of a jetliner. When it slowed down at the continental shelf, that kinetic energy didn't vanish. It converted into potential height. The Fukushima seawall stood 10 meters tall at its best section. The water arrived at 14. You don't need a PhD to see that the math of civil engineering was obliterated by fluid mechanics before the first drop even touched the coast.
They gambled on probability, Mark. That is the crime. TEPCO looked at the historical seismic data and cherry-picked the numbers that fit the budget, ignoring the black swans. The wall created a psychological kill zone. The people looked at that gray concrete monstrosity and felt safety. They didn't run fast enough because the wall promised protection that the corporate accounting department knew it couldn't deliver if the worst-case scenario hit. And guess what? The worst-case scenario doesn't care about your quarterly profit margins.
The protection was a structural illusion. The problem with seawalls, specifically gravity walls like Fukushima, is that they are designed to resist static horizontal pressure. They are built to say no to water. But a tsunami of this magnitude isn't asking for permission. It carries debris, cars, houses. It is a liquid battering ram. When the water went over the top, the overtopping, it didn't just flow down the other side. It began to erode the back foundation of the wall. Physics calls this scouring. The wall didn't just fail because it was too short. It failed because the very dirt it was anchored to was liquefied by the turbulence of the water it was supposed to hold back.
Calculated negligence. That's what we call it in the corporate world. They have reports. They knew about the Jogan earthquake of 869 AD. They knew the region had a history of megathrust events that made their design specs look like a joke. But upgrading the wall meant admitting the nuclear plant, the cash cow, was vulnerable. So they kept the illusion that wall was a monument to bureaucratic arrogance. It stood there, tall and proud, a symbol of security, while the Pacific was winding up a 40-meter-high rebuttal argument.
And the rebuttal was absolute. When the wave hit, there was no negotiation. Structural integrity is binary. It holds or it fails. At Fukushima, the failure was catastrophic because the design assumed a maximum ceiling of violence that nature never agreed to respect. We looked at concrete and saw strength. The ocean looked at it and saw a temporary speed bump. What we are about to dissect isn't just a natural disaster, Elena. It is what happens when ego-based engineering collides with unrestrained kinetic force. To understand why the wall died, you have to understand the assassin. Most people visualize a tsunami like a surf wave, a crest that breaks and crashes. That is surface-level physics. A tsunami generated by a magnitude 9.0 subduction event is not a wave. It is a displacement of the entire water column, from the surface down to the seabed. When the wave hit the coast of Tohoku, it had a wavelength of hundreds of kilometers.
And the wall was designed for a sprint, but it got hit by a marathon. TEPCO's engineers designed the seawall based on the Japan Society of Civil Engineers methodology. which focused on design basis tsunamis. They looked at the Shionyazaki earthquake of 1938 as their benchmark. They prepared for a localized event. They literally ignored the geological record of the Jogan tsunami of 869, which had wiped out the exact same coastline a millennium earlier. Why? Because acknowledging a 1,000-year cycle ruins the amortization schedule of a 40-year nuclear plant.
The mechanics of the failure were brutal. When the water level exceeded the 10-meter height of the wall, we saw the waterfall effect. This is where the engineering gets ugly. As the water cascaded over the top of the levee, it hit the unarmored soil on the landward side. The kinetic energy of falling water is immense. It drilled into the ground, scouring away the earth that supported the wall from behind. It's called toe scour. The wall didn't just get pushed over, it was undermined. The foundation vanished because they didn't pave the backyard.
Think about the negligence in that detail. They spent billions on the ocean-facing side, steel, reinforced concrete, geometric wave breakers, but they left the back exposed. It's like wearing a bulletproof vest but leaving your back naked, in a crossfire. They assumed the wall would never be breached. That assumption is the most expensive line item in history. By the time the water breached, the cooling pumps were already doomed. The wall, which was supposed to be the primary defense, turned into a weir that actually trapped water inside the plant complex, flooding the diesel generators.
Exactly. The wall became a prison for the water. But let's look at the blind spot. The seismic hazard maps pre-2011 assumed that the plate boundary off Tohoku couldn't generate a magnitude 9.0. They thought the fault was segmented, broken into smaller pieces that couldn't rupture all at once. They were wrong. The fault segments ruptured in a chain reaction, unzipping the ocean floor for 500 kilometers. The energy release was cumulative. The seawall was fighting a force that the blueprints said was theoretically impossible.
Theoretically impossible is corporate code for too expensive to mitigate. In 2008, an internal TEPCO simulation actually predicted a wave of 15.7 meters if a similar earthquake occurred. They had the data mark. The simulation was sitting on a hard drive 3 years before the disaster. The cost to upgrade the seawall and move the pumps to higher ground, a few $100 million. The cost of the cleanup, it's currently estimated at over $200 billion, and climbing. They saved pennies to burn billions.
And that brings us to the hydrostatic paradox. Even if the wall had held structurally, the pressure differential was lethal. The ocean was pushing with millions of tons of force on one side. The ground on the other side was shaking. The shear stress snapped underground piping and compromised the intake channels. The wall was a monolithic symbol, but the infrastructure connected to it was brittle. We focus on the height, but the failure was systemic. You can't stop the ocean with a single line of concrete when the ground beneath you is turning into a liquid.
The aftermath isn't just radiation, it's the total bankruptcy of the safety myth. Post-Fukushima, the Japanese government embarked on a construction frenzy, 400 kilometers of new, higher seawalls. They are spending $12 billion to build concrete barriers that are 15 meters high. It sounds impressive until you look at the ROI. Critics call it the Great Wall of Japan. It's a massive transfer of public wealth into the hands of construction conglomerates driven by political panic rather than rational risk assessment.
From an engineering standpoint, these new walls are dinosaurs. We are doubling down on resistance when we should be focusing on resilience. A static wall has a failure point. Once you exceed that point, the result is catastrophic, total loss. Resilience means designing systems that can fail gracefully. Instead of a higher wall, you need defense-in-depth wave breakers offshore to kill the kinetic energy before it hits the coast, green belts of pine forests to dissipate flow, zoning laws that forbid building critical infrastructure in the inundation zone.
But zoning laws don't generate contracts, Mark. Pouring concrete does. The logic hasn't changed. They are still trying to engineer a solution to a problem that is fundamentally about geography. The residents hate these new walls. They cut off the view of the ocean, killing tourism and the local fishing economy. It's a sunk-cost prison. They are destroying the economic viability of these coastal towns in the name of saving them. It's the same logic that doomed the plant, prioritizing the structure over the ecosystem it exists within.
The physics of the overtopping issue remains. Even a 1.5-meter wall can be topped by a 2.0-meter wave. Nature always has a bigger hammer. The shift in global engineering is moving towards safe-to-fail designs. If the water gets in, how do we get it out? How do we waterproof the generators? At Fukushima, the diesel generators were in the basement. That's not physics, that's stupidity. You don't put your life support systems in the flood zone. The wall made them lazy. It made them think they didn't need to waterproof the components behind it.
That is the takeaway. The Indomitable wall was a narcotic. It lulled the regulators, the public, and the operators into a sleepwalk. When you build a fortress, you stop checking the locks on the back door. The financial lesson here is brutal. Efficiency without redundancy is suicide. TEPCO optimized their operations for a narrow band of reality. When reality widened, they were insolvent. The stock crashed by 80%. The executives faced criminal charges. The reputation of Japanese engineering took a hit that will last a generation.
We have to stop looking at these structures as shields. They are speed bumps. The 2011 event proved that the Earth can release energy on scales that make our steel and concrete look like papier-mâché. The seawall at Taro, known as the Great Wall before 2011, was destroyed just as easily as the one at Fukushima. Physics doesn't care about your reputation or your nickname.
The final bill for Fukushima will likely exceed $500 billion when you factor in the compensation, decommissioning, and soil decontamination over the next 40 years. $500 billion for the lack of a few meters of concrete and better placement of backup generators. It is the single most expensive error in the history of commercial enterprise.
So when you look at a massive seawall, don't see safety, see a challenge. The ocean is watching that wall, waiting for the plates to slip again, and next time the water might not just go over it. It might go through it,